Our last video essay here was a very lengthy exposition of a framework which I have come to term the Noetic ether theory, a conceptual system through which I am attempting to expand my overall metaphysical and epistemological project so as to begin to account for the world of electromagnetism, gravity, and physicality itself. This video will be a much more concise and straightforward articulation of the basic concepts which comprise the Noetic ether framework, one which will also begin to elaborate certain aspects of the theory so as to lay the groundwork for future explorations. What we will be attempting to explore here is the ontological character of nature in general, the world which our consciousness actually encounters. This project is fundamentally an empirical project, one which must begin and end with the world which is actually disclosed by human experience. The most fundamental feature of our experience of the world is animacy. We find ourselves to be alive within a living world, and therefore we must begin by taking account of what this aliveness truly amounts to. Perhaps the most primary aspect of our experience is that it is characterized by our bodily composition. Our consciousness finds itself to be conditioned by our eyes, hands, and mouths, the points of contact between our own selves, and a world which is not quite self, but also not quite other. We find our consciousness to be intimately interwoven with the world around us and with our own bodies, and yet there is indeed a kind of otherness to this corporeal realm. Examine your own hands and you will find the inheritance of the past. Tiny scars which have been carried forward into this moment from previous events. Patterns of lines across your palms which speak to the inheritance of living forms which were crafted by this world independently of the agency which you might feel within the present moment. Your own body and the bodily composition of the world around you are both complexes of decisions which have already been made, determinations which have already come to solidify and to be passed on through time so as to become participants within your present moment of experience. We can thus conclude that the otherness of the corporeal world is that its composition exists independently of your own agency, and that one's own body is a kind of liminal space between selfhood and otherness. Your body is animated by your own consciousness within the present moment, but this animation is not unconstrained. It is necessarily a negotiation between the possibilities which are felt within the present moment and the determinations which we inherit from the previous decisions of ourselves and others. In contrast to this corporeal aspect of our existence, we find experiences of possibilities, and the sense of agency we feel as we navigate such fields of potentiality. Each moment is a decision in some sense or another. We choose which words to speak or what steps to make. We choose what facets of our experience are to be emphasized by our consciousness and which are to be ignored. We feel the lure of certain possibilities and act so as to bring about their realization, striving to bring the form of the possible into an informing of the corporeal. Decisions are thereby enacted and new droplets of actuality are incorporated into the body of nature. Within classical Greek philosophy, the term nous referred to the aspect of human consciousness which directly encountered forms as such. The nous is the organ of the human being which continually molds itself into the shape of the potentialities which we navigate within our living experiences. It is our capacity to make contact with forms as such, and thus the locus of our sense of inner will and connection to the transcendent. We can thus begin to understand animacy in general as a fundamentally dipolar process, one which consists of both corporeal and noetic aspects, both inheritances of the past as well as the navigation of indeterminate possibilities. Given that this is the basic structure of our empirical experience of being within the world, then we will presume that this basic structure is in fact the basic structure of the processes which constitute the world itself, unless we encounter some concrete empirical reason to presume otherwise. So now we can begin to look at the wave-particle duality of modern physics, and the way in which this apparent ontological contradiction is accounted for by the noetic ether. Rather than understanding the basic constituents of physical reality as being particles which exhibit wave-like properties, we will instead understand the basic constituents of reality to be self-generative, organic processes which are characterized by both noetic and corporeal poles. The noetic pole of an organism is a field or distribution of possible interactions, possible transmissions which might occur between such noetic fields. These noetic fields are comprised of noemata, experiences of potentialities or forms which might come to characterize the interaction events between noetic fields. Unlike physically determinate interactions, noemata themselves are not characterized by mutual exclusivity. A potentially indefinite range of potentialities can be encompassed by the noetic pole of a given organic process. Noetic fields, in other words, are fundamentally indeterminate, as they are that which conditions the possibility of determinate physicalities. The corporeal pole of an organic process, then, consists in experiences of previous interaction events. An organism's corporeal pole incorporates the concrete physical determinations which have already come to be established by the self-organization of processes which have already occurred. These corporeal experiences of past determinations are inheritances. The past determinations are incorporated into the structure of the subsequent moment of self-generation, such that the past determinations come to inform and constrain the morphology of subsequent processes. Noetic fields are fundamentally non-local, as they are ontologically prior to geometric space. The noemata themselves are, in a sense, both everywhere and nowhere, though the physical interactions or transmissions which they come to generate are localized within geometric space. Geometric space is the manner by which past determinations are hierarchically organized. A past determination which is closer to an ongoing process in geometric space or sequential time is a past determination which is of higher priority than one which is more distant. Higher priority here means a greater influencing of subsequent events through their incorporation into subsequent events. Noetic fields are fundamentally harmonic in nature. They are dynamic, oscillating systems of density and vacuity, which we could understand as relations of positive and negative energy. Density here refers to a kind of excess, which is fundamentally expansive in nature. Waves of density attempt to expand outward and therefore also exhibit repulsive behaviors. Vacuity, on the other hand, represents a kind of absence, a negativity which positive density attempts to fill. Vacuity thus represents attractive and contractive forces, which reciprocate the expansive and repulsive tendencies of density. Through the dynamic interplay of this fundamental polarity, noemata come to exhibit oscillatory, resonant, harmonic behaviors which lay the groundwork for the emergence of the atomic, astrophysical, molecular, and biotic worlds, wherein we encounter more complex permutations of these same fundamental processes. Repulsion and attraction become circulatory flux. Expansion and contraction become repetitive pulsation. The basic elements of animacy come to emerge from the fundamental musicality of being. Although noetic fields themselves are pre-spatial, they are structures of possible interactions, and interactions themselves come to be localized in geometric space and sequential time. As such, the noemata which comprise noetic fields can interact with one another on the basis of geometric locality, through processes such as interference, though not all such interactions are conditioned by such geometry. For reasons which will become clearer later on, atomic organisms continually produce both outflows of density waves as well as inflows of vacuity waves, and it is through such inflows and outflows that the basic dynamics of matter come to emerge. We can see these dynamics expressed in a relatively straightforward manner within the behaviors of macroscopic magnets. The noetic fields of the atoms which comprise a magnetized metal object come to merge together so as to form an organic whole, one which will be characterized by a macroscopic circulatory system of noemata. Currents of density will flow out from the magnet's north pole and then come to reconverge into the magnet's south pole. When two north poles or two south poles of a magnet are brought together, the currents of noetic density flow concurrently with one another, thus interacting constructively and amplifying one another. Due to the expansive nature of noetic density, this results in a repulsion between the two poles. Conversely, if opposite poles are brought together, the currents of noetic density will flow in opposite directions, thereby interacting destructively with one another. This will create a net vacuity, thereby resulting in the opposing poles being attracted to one another as positive density attempts to fill the vacancy created by destructive interference. Once the two poles come into contact and the mediating vacuity is fully subsumed, the noetic fields of the two magnets will have merged into a singular circulatory system. Symbiosis will have been achieved. We can see this exact same process at work within the electromagnetic fields produced by electrical circuits. Within this diagram, we see a cross-section of the electromagnetic field structure which issues from a circuit. The solid, concentric field lines are magnetic, while the broken, radial lines are electrostatic. Here we can see that the electrostatic field lines are in fact patterns of interference, which emerge from the interaction of the magnetic fields which emerge from the two terminals of the circuit. The magnetic field lines represent circulatory patterns of ether density, while the electrostatic field lines represent patterns of vacuity which result from interference. If the two terminals are moving in opposite directions, then the right-hand rule will determine that the magnetic circulations will flow concurrently with one another. The flows of ether density will synergize with one another, thus resulting in an amplification of density and consequently an amplification of repulsion. If the currents are moving in the same direction, however, the magnetic circulations will flow in opposition to one another, resulting in destructive interference, and thus an attraction between the two currents. To explore more deeply the nature of electricity, we must begin to understand the etheric, noetic nature of the atom. In order to do so, we must understand how atoms may have initially formed within the processes of cosmic evolution. As such, we must begin by asking what the overall topography of our universe as a whole must be. One common suggestion pertaining to the topography of our cosmos is that it may be curved into a kind of hyperdimensional toroid due to a cosmic deformation of space-time. This possibility, of course, presumes an Einsteinian relativistic cosmology, one which is fundamentally at odds with the noetic ether theory. But even independently of the question as to whether deformation of spacetime is actually a real phenomenon at all, we have empirical reasons for discounting this possibility. Attempts to measure the curvature of the universe itself have consistently demonstrated no observable curvature, implying either that our universe is not in fact curved upon itself in such a manner, or that the universe is so unimaginably vast that such curvature cannot be detected. As this possibility lacks empirical support, we should instead consider other possibilities. Another possibility is that our universe is in fact infinite, that space is utterly indefinite and boundless. This, however, is not a genuine possibility, as it relies upon an incoherent misapplication of the notion of infinity, one which we can see clearly illustrated in Zeno's paradoxes. Zeno asks us to consider the fact that an arrow, after being fired at a target, must cross half of the distance to the target before it can arrive at its destination. In order to reach the halfway point, however, the arrow must first cross 1/4 of the distance. In order to cross 1/4 of the distance, however, the arrow must first cross 1/8 of the distance. Zeno reasoned that if this is indefinitely the case, then motion itself should not be possible. The arrow will need to cross an infinite number of indefinitely minuscule fractions of distance before it can ever reach its destination, and therefore reaching any destination would require an infinite amount of time, no matter how small the distance between two locations. Modern philosophers tend to dismiss Zeno's paradoxes by invoking the notion of limits, that an infinite series can asymptotically approach a finite number, and therefore this somehow means that the arrow can still reach its target despite having to cross an infinite number of fractional lengths. This dismissal, however, ultimately resolves nothing and only adds to the confusion which results from treating infinity as a number in this way. An infinite series of fractional distances might add up in such a manner so as to approach the distance between the arrow and its destination, but this still implies that the arrow will never actually arrive anywhere. It will, over the course of an infinite amount of time, become ever closer to its destination without ever actually reaching it. An infinite number of infinitesimally tiny units of time still adds up to infinity just the same. Within his 1927 Process and Reality, the British-American mathematician and metaphysician Alfred North Whitehead addresses this problem by suggesting that indefiniteness is fundamentally a property of potentialities, but not actualities. If I have a 2-meter long wooden board, then we can say that this length can be indefinitely divided in potential, but in reality the board will always be characterized by an actual specific length. The actual board is not comprised of an infinite series of indefinitely small fractional lengths. Likewise, with time, we can say that a moment can potentially be subdivided indefinitely, insofar as processes of shorter duration might occur within the confines of the total duration. But this does not mean that the total duration is composed of an infinite number of infinitesimal time units. The real duration has a real determinate value, which is defined in contrast to other real durations. As such, we can see that although we can potentially divide the wooden board an indefinite number of times, there cannot actually be an indefinite number of board segments. Likewise, there cannot be a literally infinite number of stars, galaxies, or atoms within our cosmos. The only remaining possibility, then, is that our cosmos is looped, not in that its 3-dimensional structure is folded into a 4-dimensional hyperspace, but simply because all directions ultimately reconnect with themselves. Our universe is not curved into itself, but rather mirrored in a sense. If we begin to imagine the evolution of our cosmos by presuming such a reflective topography, we can begin to speculate as to what the earliest phases of cosmic evolution may have been. We can presume that the most primordial state of the natural world consists of a vast, uniform distribution of minute ether fluctuations, a kind of ground state characterized by disturbances, which we could correlate with the notion of quantum vacuum fluctuations or the electropositronic disturbances within the Dirac-Sea hypothesis. Each fluctuation of density will be accompanied by a correlative fluctuation of vacuity. Positive and negative intensifications will counterbalance one another such that the overall density of the cosmos will be zero. We can thus refer to the baseline equilibrium state of the noetic realm as the zero field, a notion which we might correlate with esoteric notions such as Brahman or the Akasha within Indic philosophy, or the abyss or abground of the German phenomenological tradition. Presuming that density fluctuations correspond to positronic fields, while fluctuations of vacuity correspond to electronic fields, we can then infer that such perturbations would become dynamically entangled with themselves so as to form electromagnetic wave propagations, fluctuation systems which consist of a symbiotic interplay of positronic density and electrostatic vacuity circulations. These propagations will radiate outward from their origin, but due to the mirror-like nature of the cosmic zero field, these outward propagations will ultimately loop back upon themselves. As such, all outward, expansive propagations will become folded in upon themselves so as to form an influx of contractive waves. No matter how minuscule the initial fluctuations may have been, this recursive dynamism will inevitably result in an increasingly intense and unimaginably vast vortex of density and vacuity field fluctuations. Within this cosmic vortex, electromagnetic propagations will come to be curved into closed, circular rings. The electromagnetic organism will begin to repeatedly undergo transmissions with itself, thereby forming a recursive, self-perpetuating system of luminal density and vacuity. Electromagnetic propagations themselves come to generate cylindrical electromagnetic circulation systems in much the same manner as what we see in electrical circuits. Within a closed luminal ring as described above, such a cylinder of electromagnetism will come to form a toroidal structure. Within such a structure, an interplay of two conflicting forces will arise. Due to the right-hand rule, the magnetic density circulations will move concurrently with one another, thus interfering constructively and thus generating a repulsion which will attempt to push the luminal circuit apart. Counteracting this will be the force of magnetic pressure, which will create a contractive force which will attempt to collapse the toroidal structure into itself. Given a sufficiently small initial radius, the contractive power of magnetic pressure will ultimately prevail, resulting in the implosion of the toroidal ring into a spherical structure. This sphere will thus become an oscillating spherical dipole of positive energy and negative energy, density and vacuity. The two spherical layers will repeatedly oscillate in a manner analogous to a spherical standing wave. Put another way, we could also describe this structure as an oscillatory spherical dipole of electronic and positronic droplets of consciousness. This metamorphosis of the electropositronic toroid into the electropositronic sphere is in fact the transmutation of the neutron into the hydrogen atom. Matter is quite literally frozen light, as it were. Moving forward, the terminology we will be using will in many ways differ from the terms which are typically used in discussing the nature of the atomic realm, and this is an intentional decision. Terms like proton, electron, let alone quarks and gluons, are themselves the result of an enormous amount of confusion, and insofar as we will be using these terms at all, we will be contextualizing them in a very specific way so as to avoid ambiguity. The oscillation of the hydrogen core will result in the emergence of two counterbalancing wave structures, or auras. The oscillations of the density or positronic layer will result in an outward radiation of density waves. The oscillations of the vacuity or electronic layer will result in an influx of contractive vacuity waves. Through the dynamic interplay of these expansive and contractive flows, a shell complex of spherical standing wave patterns will come to form, the so-called electron orbitals. What is being indicated here is that the standing shell complex is not in fact the electron, insofar as that term is taken to indicate a structure of negative ether density. As we have already begun to see, the structure of negative ether density, or vacuity, is actually contained within the structure of the atomic core itself, where it participates in a dynamic of reciprocal oscillation with a correlative structure of positive ether density. The standing wave shell structures are instead the consequence of the harmonic complexifications which the inner vacuity spheres contribute to the atomic morphology. The process of negative ionization comes about as an atomic core absorbs an additional vacuity sphere. When this occurs, the additional vacuity sphere comes to create a dual oscillation pattern in relation to the underlying spherical dipole structure. The two poles of the underlying core layer oscillate in relation to one another, and that dipole layer as a whole oscillates in relation to the additional anionic vacuity sphere. Through this process, the harmonic complexity of the atom is increased, resulting in the creation of a new standing wave shell structure around the atom. The anionic vacuity sphere oscillations will create a new influx of vacuity waves at a lower frequency, and the oscillation between the anionic vacuity sphere and the underlying dipole will also cause the density sphere to oscillate at the lower frequency of the anionic sphere in addition to its original frequency within its original dipole oscillations. Density layers contribute to mass, inertia, and gravitation, while vacuity layers condition the harmonic structure of the atom's radiant aura. Conversely, positive ionization comes about as an atomic core loses an electronic vacuity sphere. The positronic density sphere of the atom's outermost dipole layer comes to oscillate in relation to a sphere of zero density, rather than in relation to a correlative sphere of negative, vacuous energy. This loss of the vacuity sphere results in the loss of a standing wave pattern within the atom's aura, as the outward propagations of the density layer are no longer reciprocated by a corresponding influx. The density wave propagations which radiate outward from the atomic core will constitute the atomic mass field, a structure which will determine the mass, inertia, and gravitational influence of the atom. Assuming that the atom maintains a constant velocity, the atom's mass field propagations will flow with the same velocity in all directions. There will be no Doppler effect, in other words, as the mass field propagations will flow out from the atom uniformly, irrespective of any given constant velocity of the atom. Given that the atom maintains a constant velocity, then, it will encounter no resistance from its own mass field. It will proceed as though it were at rest because any constant velocity will be an effective resting state in relation to the atom's mass field. Conversely, if the atom were to alter its own speed or direction of motion, such acceleration would result in a compression of mass field propagations due to the Doppler effect. The atom will thus require energy expenditure in order to alter its own resting trajectory, as doing so will result in the atom encountering resistance from its own mass field. Effective inertial mass of the atom's mass field is in fact atomic rest mass. Atoms will follow the resting trajectories which are defined by their own mass fields, but such resting trajectories needn't be straight lines. In fact, due to the inherent interrelatedness of all matter, no resting trajectories are ever truly straight line trajectories. As the mass field propagations of each atom radiate outward indefinitely, the mass fields of every single atom in the cosmos will envelop those of every other atom in the cosmos. As such, patterns of constructive and destructive interference will alter the density gradients of atomic mass fields in such a way that resting trajectories come to be deformed into curves. Atoms will follow the path of least resistance, which is defined by the surrounding etheric density gradients, and such resting trajectories will be defined as elliptical, parabolic, or otherwise curvilinear paths due to the interactions between overlapping mass fields. Inertial mass is mass, and gravitation is the deformation of inertial trajectories through the influence of mass field propagations. Given that gravitational and electromagnetic phenomena are both fundamentally etheric phenomena, this may then imply that electromagnetism and gravity may be able to interact with one another in ways that are as yet unaccounted for by orthodox physics. Stellar, galactic, and intergalactic structures of electromagnetic circulation may come to alter the morphology of mass fields, such that gravitational influences occur in ways that are much more complex than might otherwise be assumed. The ever-elusive and blatantly non-existent dark matter of orthodox astrophysics may in fact be the morphogenetic interplay of electromagnetic fields and atomic density fields. This further implies that empty space is not in fact empty, and for multiple reasons. On the one hand, the zero field itself is a boiling cauldron of density and vacuity fluctuations. Paul Dirac predicted this as being a consequence of his electrostatic vacuum, or Dirac-C hypothesis, that seemingly empty space would constantly produce positive and negative energy fluctuation pairs, which would then combine with one another, a churning ocean of electronic and positronic energy. When electrons and positrons combine with one another, they become electromagnetic propagations, and thus we would expect this zero field, or Dirac-C, to produce a constant flow of electromagnetic radiation. Within orthodox physics, this conclusion is accepted as a consequence of the Dirac equations, but these fluctuations are said to be merely virtual particles, which simply blink in and out of existence without actually producing electromagnetic radiation. However, there is no actual distinction between real and merely virtual particles to be found within Dirac's theory, and Dirac himself indicated no such thing. If we actually take the implications of the Dirac-C and the Noetic Aether model seriously, then we should expect these fluctuations and the electromagnetic waves they would produce to be just as real as anything else in nature. The cosmic microwave background radiation is typically said to be a sort of echo of the Big Bang, the singularity at the beginning of time within which all of the centropy of our cosmos was contained, which is now winding down into an inevitable heat death of entropic equilibrium. The cosmic microwave background is said to be direct evidence of this initial detonation, and cosmic redshift is said to be evidence of the expansion of Einsteinian spacetime, which continues the gradual explosion of our universe into entropic nothingness. There are many issues with these interpretations, however, and I've included a link below to a very thorough playlist by the channel Sky Scholar, which details the numerous conceptual and empirical failures of the Big Bang interpretation of the microwave background radiation. What I would like to suggest here, however, is that this background radiation is not an echo of the Big Bang at all, but rather is the radiation which is being constantly produced by the zero field, Dirac sea, or quantum vacuum itself. Likewise, interpreting cosmic redshift in the orthodox manner is equally unworkable. Cosmic redshift refers to the observation that the electromagnetic radiations produced by distant astrophysical objects tend to be shifted towards lower wavelengths for more distant objects. Orthodox physics interprets this redshift as the result of the expansion of spacetime itself. More distant astrophysical objects are moving away from the Earth at faster speeds, so we are told, due to this expansion, and therefore the electromagnetic emissions of such objects become elongated by this expansion, shifting these emissions towards lower wavelengths. Numerous observations, however, indicate that the quasars produced by galactic nuclei tend to have substantially higher redshift than the galaxies that they are a part of. The core of a galaxy cannot be moving away from the Earth faster than the galaxy it is a part of, and physicists have needed to invoke numerous ad hoc justifications for this by explaining this phenomenon as being due to line-of-sight coincidences, lensing effects, or other such distortions. Here, however, we can suggest a much more self-consistent interpretation. The empty intergalactic space which these emissions pass through is not in fact empty. As we have already seen, the mass fields of each and every atom are of an indefinite radius. These fields extend out indefinitely, and although these fields quickly diminish with distance, they only asymptotically approach zero, meaning that every atom in the universe will have a non-zero influence upon the ether density of every single point in space. Although these influences would be quite negligible at smaller scales, over the immensely vast expanses of intergalactic space, these influences would become far more substantial, and would create a resistance which would act to gradually reduce the energy, and thus wavelengths, of electromagnetic emissions which travel through intergalactic space. By looking more closely at the nature of light itself, we can begin to further expand upon the implications of the Noetic ether framework. Even a seemingly mundane phenomenon such as the refraction of light poses a seemingly insurmountable theoretic impasse for the materialistic framework of orthodox physics. Initially, it would seem that this phenomenon could be understood in a relatively straightforward manner. Light passes through a medium, and this medium then alters the electromagnetic propagations such that the light is bent. But even as early as the 17th century, scientists were already beginning to see that the reality must be stranger than this physicalist interpretation might imply. In 1662, the French mathematician Pierre de Fermat showed that the refraction of light behaves in accordance with the principle of least time, which we can see as an early form of the principle of least action. What Fermat seemed to show was that the light was not simply being deflected by the medium within refraction phenomena, but rather that the light seemed to be actively choosing the quickest path between its origin and its destination. This, of course, seemed to raise some very difficult implications. How could the light possibly know where it was going in advance, such that it could somehow choose the most parsimonious trajectory? Some physicists have taken this to imply some sort of reverse causality, by which the destination atoms somehow transmit information backwards in time to the atoms which emit the photons. But if we look at this situation in terms of a field transmission duality, rather than a wave-particle self-contradiction, then refraction becomes much less mysterious. The electromagnetic wave propagations are fields of possible transmissions, not the transmission events themselves. The former are noetic rather than concrete. While the photonic transmissions occur within geometric space in a physical manner, the field propagations themselves are fundamentally pre-spatial. They do not require time to move through space because although they condition the possibility of transmissions which will occur within geometric space, they themselves are, in a sense, everywhere and nowhere at the same time. The photon takes the path of least time to the destination because the electromagnetic field is, in a sense, already enveloping all possible destinations, and thus including within its structure all of the possible pathways which could be taken by the resultant transmission. Light, therefore, is not an electromagnetic propagation in itself. Rather, light is a kind of communication between atoms which is facilitated by electromagnetic propagations. The photonic transmissions which make up light consist of specific trajectories through geometric space, but the superluminal field propagations which facilitate photonic events are themselves non-local. They do not require time to travel through geometric space, as only the transmissions themselves are truly localized physically. Within the double slit experiment, we can see that the double slit apparatus causes light to exhibit an interference pattern, even if the photonic transmissions occur one at a time. The materialistic metaphysics of modern science can only see this as an incomprehensible paradox, but here we can see that this is quite understandable. The superluminal field propagations which ontologically precede light are non-local and thus able to interfere with themselves, while the consequent transmission events, or photons, occur as discrete, localized interactions between specific atoms. What this then implies is that such non-locality is a property of all noetic fields, and thus all electrical and magnetic fields, and thus all atomic fields, and thus, as we shall see, all bioelectric fields as well. During the 20th century, the theoretical physicist David Bohm came to very similar conclusions for a number of very similar reasons. Bohm came to realize that numerous natural phenomena, including the behavior of light, electrostatics, magnetism, gravity, and plasma phenomena, all seem to necessitate what Bohm would call the implicate order. Quote, "The essential feature of the implicate order is that the whole universe is in some way enfolded in everything, and that each thing is enfolded in the whole. In the implicate order, everything is connected, and each part of the universe contains information about the whole. In the explicate order, things are unfolded and are seen as separate and distinct. In the implicate order, things are enfolded into one another and are fundamentally connected. The explicate order emerges from the implicate order through a process of unfolding, and the implicate order can be seen as the deeper reality underlying the explicate appearances." End quote. Bohm saw that the world which our physical senses encounter is in fact the activity or consequence of a much deeper reality, within which all things are always already interwoven with one another. Physical determinations are therefore not the fundamental substrate of nature, but rather the unfolding of this implicate realm through the concrescence of animate processes. Thus we can see that Bohm's implicate order is the noetic realm of conceptual, formative relationships rather than relations of physical determinations or sensations, a realm of morphogenetic spaces rather than geometrical spaces, of diffuse, indeterminate potentialities rather than of the concrete determinations which comprise the physical, explicate realm. It is, in other words, the ether which remained ever elusive to scientists of the 19th century who were unable to conceptualize the ether as being anything other than a kind of fluid substrate due to their own materialistic presuppositions. Rather than conceptualizing the ether as a kind of fluid substrate which physical phenomena swim inside of, it is more accurate to conceptualize the ether as radiating outward indefinitely from each and every entity within the cosmos, as a kind of aura through which all things envelop all other things, thereby conditioning the interactions between them. In terms of physical geometric space, this is an accurate description, but we must also keep in mind that even this is in some sense an abstraction, as the conceptual feelings or noemata which comprise these morphogenetic fields are fundamentally pre-geometric. They are that which conditions the very possibility of geometric space. In other words, the specific potentialities which are felt by these etheric fields are local in the sense that each possibility specifies a possible interaction within geometric space. However, the noetic or conceptual experiences themselves are better understood as being projected into geometric space from the implicate, morphogenetic space which underlies it. Even more accurately, we could say that geometric space itself is in fact the result of this noetic projection. This understanding led David Bohm to the conclusion that the geometric, explicate order is the holographic consequence of the implicate, noetic order. Atoms emit light when their electrostatic shells are expanded into higher harmonic energy states. Such higher energy states are less stable, and therefore the electrostatic shell will contract itself into a more stable state if it can. As it does so, it will produce an electromagnetic propagation, which will then facilitate a transmission of energy unto another atom. The excitation energy or instability of the transmitter atom will be translated into either kinetic, vibratory energy within the receptor atom, or the excitation of the receptor atom's own electrostatic shell. Through our noetic model of the atom, we can thus infer that this electrostatic excitation must be the expansion of the outermost dipole spheres of the atomic core, such that this valence core layer adopts a lower frequency state, one which is characterized by less harmonic stability and thus greater potential energy. The atom then attempts to resolve this instability by transforming it through communion with other atoms. Through photonic transmissions, this instability can come to be dispersed in such a manner that an overall equilibrium is achieved. What this then implies is that heavier atoms must consist of numerous dipolar core layers which are nested within one another so as to form complexes of numerous harmonic energy states. As we move outward from the innermost core layer, each subsequent layer will correspond to a lower frequency outflux of density waves and a lower frequency influx of vacuity waves. These patterns of influx and outflux will then correlate with new frequency patterns within the standing waves which constitute the electrostatic shells. Within the dipole layers which constitute the atomic core, density spheres contribute primarily to increasing the strength of the atomic mass field, thereby contributing to inertia and gravitational influences. Vacuity spheres conversely contribute primarily to increasing the harmonic complexity of both the core itself as well as the electrostatic epidermal complex which surrounds the atoms. We can also see here that the electrostatic standing wave shells are not simply barriers with finite dimensions. As with the mass fields they adhere within, these electrostatic complexes radiate outward indefinitely from each atom. They are auras which envelop the entirety of our cosmos. As we have already implied, the neutron is in fact the toroidal modality of the hydrogen organism, which is maintained prior to its collapse into its more stable spherical morphology. Within larger atomic complexes, these neutronic toroids envelop the atomic core, contributing an inward pressure which contributes to stabilizing the core structure, as well as contributing to the overall inertia or mass of the atom. Vacuity spheres only contribute to the overall inertia of the atom indirectly through the energy which is contained within the electrostatic shells which they produce. These electrostatic epidermal structures are also the organs through which atomic symbiosis is facilitated. Covalent bonds occur through a mutual resonance between electrostatic spheres, which produces additional harmonic overtones which are shared between the electrostatic shells of the two atoms. These covalent frequency patterns increase the overall stability of the electrostatic spheres which they come to form within, and therefore the separation of the bonded atoms will require energy in order to counteract this stability. In other words, the path of least resistance for such atoms will be towards one another, and thus the atoms will become conjoined with one another. When two atoms participating within a covalent bond are of different size, their mass fields will likewise be of different overall densities. Destructive interference between the two will result in a net imbalance. The smaller atom's density field will be reduced to 0 or less in certain regions, while the density field of the larger atom will be diminished, but still net positive. As such, the excess density waves of the larger atom will begin to flow into the vacuity sink of the smaller atom, forming a polar covalent circulatory system, much like what we see in macroscopic magnets. Within modern chemistry, it is generally presumed that even though the electrostatic shells of atoms are quantum, or rather noetic fields, the frequencies of the electrostatic shell layers are nonetheless deterministic in a sense. It is said that each so-called orbital consists of a specific wavelength, which relates to the radius of the sphere by a simple harmonic mode. The electrostatic shells of the atom are certainly organized into discrete energy levels, and within our etheric model we can see that this is due to the fact that each shell is the result of a specific vacuity sphere within the atomic core. Although these energy levels themselves do indeed appear to be discrete in a sense, it nonetheless does not necessarily follow that the standing wave patterns within each energy level are necessarily confined to a specific wavelength and frequency. Within quantum mechanics, it is understood that quantum waves are in fact wave packets, which consist of a composite of numerous potential frequencies and wavelengths. It is said that the quantum entity's frequency and wavelength, along with other variables, are not determined until a particular interaction event occurs, thus collapsing the wave function. Such noetic fields, in other words, consist of a plurality of possible variables because those properties are only determinate for the discrete interaction events which occur between such fields. Thus, we can infer that the atomic core layers and the electrostatic shell structures which surround the atom are not actually confined to particular frequencies, but rather consist of a potentiality distribution of possible frequencies, a composite image, as it were, in which each possible frequency corresponds to a slightly different radius, but the same harmonic modality. Although this interpretation certainly contradicts scientific orthodoxy, empirical evidence once again appears to lean in its favor. The spectral lines of atomic absorption and emission patterns are never observed to be perfectly discrete values, but rather we observe that there is a probabilistic broadening of these spectral lines, which accords with the implication that the electrostatic shells are in fact composite waves. The orthodox explanation for this spectral line broadening involves the invocation of numerous phenomena such as quantum vacuum fluctuations, electromagnetic interference, and the Doppler effect. By invoking such phenomena, scientists are able to justify normalizing their data, that is, removing spectral data which doesn't accord with their assumptions about the atom by regarding it as mere noise. But here we can provide a much more straightforward interpretation. The electrostatic shells appear to be of indeterminate frequencies because they simply are indeterminate frequencies. What this would then imply, however, is that interatomic interactions in general, including bonding behaviors, are themselves indeterminate. One cannot definitively determine how atoms will come to form molecular structures on the basis of their electrostatic shells alone, because one cannot definitively predict whether or not two atoms will come to form a covalent resonance pattern or not. When two atoms interact, there is a plurality of possible frequency interaction relationships which might come to be concretized, and thus a resonant bond may or may not come to form. The atoms, in other words, must decide what sort of resonance relationships, or lack thereof, will come to form between them. It is here that we can begin to see the synergy between the noetic ether theory and Rupert Sheldrake's theory of morphic resonance. If we understand noetic fields, and thus electromagnetic and atomic fields in general, as being morphogenetic fields, then we can begin to understand the indeterminate, composite nature of such fields as directly related to the role of memory, which is indicated within Sheldrake's morphic resonance theory. Morphic resonance theory builds upon the relationship between matter and memory explicated by the philosopher Henri Bergson, who argued that memory is not simply a matter of information storage within physical mediums, but rather that memory is a fundamental aspect of nature itself, whereby organic processes within the present are able to actively incorporate the past into themselves. Organic memories are not stored in nervous systems in a manner which is analogous to computational information storage. Rather, the memories themselves are actually within the past itself. Organisms tune into past events such that the formative structure of a present moment can be shaped by past actualities. The formative structures of a present moment then are morphogenetic, noetic fields, distributions of possible actions and possible relationships, which the organism evaluates and thus organizes in relation to its own subjective aims. This organization prioritizes possibilities in relation to one another, thus conditioning the shape which comes to be taken by the process as it is completed and thereby incorporated into the past. It is through memory that these fields come to be shaped and reshaped over the course of time. Past actualities come to inform noetic fields, and such fields are the raw materials from which concrete relationships, definitive actions, and interactions come to be determined. If you are interested in a much deeper dive into the theory of morphic resonance, then there is a link included below to a much more rigorous investigation of this theory. For now, however, I want us to focus upon Sheldrake's research regarding the nature of molecular crystal formation, and how the seemingly anomalous nature of atomic bonding might further illustrate the noetic nature of matter itself. Morphic resonance is a theory which pertains not only to biological organisms, but to all self-organizing or autopoietic systems in general. This implies that the effects of morphic resonance should be found not only in biological organisms, but perhaps also in molecular, atomic, or even astronomical structures. For any such systems, the form which is achieved by self-organization should be shaped by the morphic influence of similar systems which have developed in the past. For systems which have existed for vast amounts of time, such as hydrogen atoms, for example, the cumulative influence of the past should be so great that such systems exhibit very little morphogenetic variability. Novel developments should have very little effect, as any such alterations should exert invisibly minuscule influence in comparison to the effects of innumerable past instances. Very old morphogenetic structures, in other words, should be far more stable and determinate than more novel structures. Conversely, the effects of morphic resonance should be much more noticeable within systems which are relatively new. Synthetic structures which have only ever been created by human artifice, therefore, should allow us to empirically observe and even measure the effects of morphic resonance. Morphic resonance should predict that synthetic chemical compounds which have never existed prior to their synthesis by human beings should initially be very difficult to create. Without the influence of past forms to guide the formation of the new substance, random chance will have a greater bearing upon the formation of the substances. Formation will be less likely to occur, and the system will break down more easily until the cumulative effects of past iterations come to stabilize the morphology of the novel chemical structure. We should expect new compounds to become more and more stable and more easily synthesized over time. Looking to the history of synthetic chemistry, Sheldrake argues that this is exactly what we find. Tyrannose, for example, is a type of sugar used as a carbon source by numerous species of bacteria and fungi, and which occurs naturally in honey. For many decades, tyrannose was considered to be a liquid, as it had only ever been observed in a liquid form. In the 1920s, however, tyrannose crystals were created for the first recorded time, and subsequently such crystallization came to be observed throughout the world. Today, tyrannose is regarded as a solid, crystal substance with a melting point of 168 degrees Celsius. In some cases, new crystal structures come to emerge which seem to replace previous forms. Xylitol, a kind of artificial sweetener, was first created in 1891 and was initially considered to be a liquid. In 1942, a crystalline form of xylitol with a melting point of 61 degrees Celsius came to develop. A few years later, a new crystal structure came about, now with a melting point of 94 degrees Celsius, and thereafter chemists found that they were unable to recreate the first crystal form, perhaps indicating that the second structure was more stable and thus was able to outcompete or overwrite the previous, less stable structure. Within the realm of synthetic chemistry and pharmaceutical manufacturing, the emergence or displacement of new forms is a well-documented and recurrent issue. The drug ritonavir, for example, was introduced in 1996 as a treatment for AIDS. After 18 months of continual manufacturing of the substance, chemical engineers came to discover a previously unknown polymorph of the compound, one which rendered the compound significantly less effective for treatment purposes. The chemists involved soon found that they were unable to prevent the new polymorph from forming, and the drug had to be withdrawn from distribution. It therefore seems that in many cases, some polymorphs form more readily than their counterparts, and the former come to outcompete the latter. As many chemists have noted, once a new crystal polymorph emerges in one location, the novel form soon comes to emerge throughout the world. Regarding this often pernicious phenomenon, the American chemist Charles P. Saylor remarked that it was, quote, as though the seeds of crystallization had been carried upon the winds from end to end of the earth, end quote. It is true that molecular crystals can act as seeds of a sort, which are able to spark a chain reaction by which the crystal formation spreads throughout a given compound. Thus, in explaining the phenomenon of new structures seeming to emerge in disparate parts of the world at the same time, chemists have sometimes suggested that such seeds travel from laboratory to laboratory upon the clothes or beards of migrant scientists, who contaminate the substances of different labs and thus spread the new polymorphs. Sheldrake, however, suggests that this phenomenon is the result of morphic resonance. Once new forms come to be achieved for a given molecular structure, the achievement of that form then becomes much more likely for all such molecular structures throughout the world. The developmental pathway of the novel form comes to condition the morphogenetic behaviors of such molecules, as such a pathway is, in a sense, made available across space and time. Given that the theory of morphic resonance implies that novel chemical structures should become more stable over time, this suggests that we should see a substantial increase over time in the melting points of synthetic crystals that are relatively new, and we should likewise see that older synthetic compounds should have notably higher melting points than newer synthetic compounds. With data collected from numerous editions of chemist handbooks printed throughout the 20th century, Sheldrake shows that, in fact, there has been an often drastic increase in the melting points of relatively new synthetic crystal structures, while the melting points of naturally forming crystals have remained almost entirely stable in most examples. This data is exactly what one would expect to be the case if morphic resonance were indeed at work in conditioning the behavior of these chemical compounds. Naturally forming chemicals have existed for a long enough time that the cumulative effects of morphic resonance have stabilized their melting temperatures. With synthetic chemicals, conversely, we see the effects of morphic resonance accumulating throughout the years since their creation by human beings. As resonance further solidifies the morphic fields associated with these chemicals, their melting points come to measurably increase. Some chemists have explained this phenomenon by indicating that these changes in the measurements of melting points could be instead due to improvements in the purity of these chemicals over time. Impurities in chemicals can in fact lower melting temperatures, though that explanation would not in itself account for the fact that such temperature change over time seems to have occurred primarily in synthetic crystals, but not in naturally occurring crystals. Improvements in purity might very well have also resulted in discrepancies over time in the measured melting points of naturally occurring chemicals as well, if the samples used were created by human manufacturing. The most typical presumption made by most scientists is that the formation of chemical compounds is determined entirely by unchanging laws which dictate the behaviors of different types of atomic elements. If one understood fully the law-like constants which dictate the natures of the atoms, then one would have a full understanding of their bonding behavior, and one would therefore be able to predict the nature of the compounds formed by these atoms. Through extrapolating from an understanding of such laws, scientists should, in principle at least, be able to predict the melting points, structures, and behaviors of chemical compounds, even without the need to actually create and empirically study such compounds. In reality, however, making such predictions is not actually possible. Scientists typically do, in fact, have to experiment and observe in order to determine the properties of chemical compounds. Their properties cannot actually be deduced in an a priori manner by inferring from physical constants. Nonetheless, the unspoken presumption generally remains unquestioned. The presumption that if these phenomena were not so complex, or if we had more detailed information about the laws which govern atomic bonding behaviors, then such predictions would actually be possible for all chemical structures. The shortcomings of this presumption can be seen quite dramatically within the science of protein synthesis. Scientists have grappled with the protein folding problem since the 1960s, when researchers began to inquire as to how exactly the amino acid sequences of proteins come to determine the complex three-dimensional structures of such protein molecules. Despite many decades of research, chemists remain unable to adequately explain how such three-dimensional structures are dictated by the behaviors and properties of the atoms which comprise them, or how protein folding is able to occur at the incredible speeds which are observed. Researchers have employed numerous computational methods in attempts to predict protein structures, though these methods have only ever achieved very limited success with very small, isolated proteins, and researchers have as yet been unable to generalize from these isolated accomplishments. In the year 2018, AlphaFold, an artificial intelligence system developed by Google DeepMind Laboratories, began to be employed by researchers in an attempt to predict protein structures. AlphaFold was a machine learning system which was trained by examining the known properties of over 170,000 proteins. AlphaFold was then used in an attempt to use this information to predict protein structures. Although AlphaFold did achieve a degree of success in making these predictions, which was much higher than what had previously been accomplished, the results it produced were far from perfect and not nearly accurate enough to allow for the discovery of new pharmaceutical compounds. More importantly, however, is that although AlphaFold was able to make somewhat accurate predictions of protein structures, it remains unclear as to how exactly AlphaFold was able to even accomplish this. If some hidden laws of nature are indeed fully determinative of protein structures, AlphaFold is still not able to actually tell us what those laws are. AlphaFold predicts the structures of proteins based on data pertaining to other proteins, and although it has achieved a relatively impressive degree of statistical accuracy in doing so, it still cannot tell us why or how proteins actually fold the way that they do. What the theory of morphic resonance would suggest is that we are not able to predict the structures of proteins based on the properties of their constituent atoms because protein structures are not actually determined by law-like, a priori constants of nature which dictate such bonding behaviors. The higher-level structures simply cannot be fully understood as derivative of lower-level constituents, as higher-level structures are achieved in an evolutionary, rather than a strictly mechanistic and reductionistic manner. The protein folding problem remains a problem not because we do not yet have the computational power needed to account for the complexity which we are faced with, but rather because the protein folding problem itself is an ill-posed problem, one which is conditioned by presumptions about nature which are themselves fundamentally deficient. What this would all indicate with regards to the fundamental structure of the atom, therefore, is that atomic wave structures are not characterized by specific, determined frequencies, but rather that such structures are in fact composites, which are comprised of an indeterminate range of possible resonance relationships which might come to obtain between atomic organisms. The atoms are able to effectively select which resonance relationships come to be corporealized. Such decisions can be weighted towards particular outcomes depending upon the overall morphology of the atom's noetic or morphogenetic fields. Certain possibilities will be felt more intensely than others and will thus be prioritized. Cosmic, astrophysical, biological, and chemical evolutions can thus all be understood as the activity of a purposive, experiential, and fundamentally organismic agency, rather than the blind, algorithmic, and meaningless turnings of sterile, mechanistic determinations. Evolution is not simply the filtering of possibilities by genetic epidemiology, but is in fact the process by which living forms come to generate themselves through dynamic dialogues with one another and with the cosmic memory that is the corporeal, explicate order. The formation of molecules is a symbiosis through which the noetic field structures of atoms merge together so as to form more complex organic wholes. This process is the exact same process through which organic wholes are generated by nature in general, and we can see this organicity even in the most seemingly mundane technological artifacts such as bar magnets and electrical circuits. Modern science tends to describe magnetism as resulting from the manner in which supposed electron particles are able to freely float around within metallic objects, as though the electromagnetic nature of metals amounted to a turbulent soup of ghostly ping-pong balls zipping in and out of existence as needed in order to make your grocery list adhere to your refrigerator. Of course, the apologists of scientific orthodoxy would protest that this is a caricature, that even though that is the explanation that is presented to us in textbooks and popular science media, that scientists actually know that this explanation is an oversimplification. But as soon as we begin to truly press the question, an oversimplification of what? It begins to become very evident that this is not an oversimplification so much as a thin facade which obfuscates the reality that there is no coherent explanation of even the most basic physical phenomena within orthodox scientific doctrines. But within our Noetic Aether framework, we can begin to actually explain such phenomena, as opposed to simply pointing to equations which can make numerical predictions and pretending that such prediction amounts to genuine understanding. Magnetic fields are circulatory systems of the noetic fields, which comprise atoms. These atomic fields merge together so as to form holistic systems, which interact with other such systems through dynamics of constructive and destructive interference. Flows of electricity generate magnetic fields because such flows weave together the atomic fields of the metals which participate in the electrical circuit. Moving magnetic fields generate electrical fields because such motion generates patterns of interference with the ever-present background of mass fields which radiate outward from all atoms. Within molecules, these atomic fields are able to form intricate, crystalline geometries of field circulation which achieve the delicate balance of stability and chaos needed for the emergence of more complex forms of life. Within biological organisms, the diversity of etheric processes come to be woven together so as to form cyclical systems, which are not only able to self-perpetuate and self-replicate, but are also able to continually recreate themselves, growing, diversifying, and interweaving endlessly through the evolutionary striving towards ever more intense realizations of harmonic complexity. Thanks for watching.